title of our paper is Understanding Android Fragmentation with Topic Analysis of Vendor-Specific Bugs. First, I will give you a quick intro to the context of our study, and then we'll go over some previous work. After going through the methodology, I will explain the results of comparing topic models, and then Xiao is going to finish with the rest, including topic analysis, fragmentation discussion, and conclusion. So, what is Android fragmentation? It can be explained from two aspects: hardware-based fragmentation and software-based fragmentation. Hardware-based fragmentation refers to the diversity of Android devices. Software-based fragmentation indicates the variety of software within Android ecosystem, including parallel Android versions deployed by Google, device-specific Android versions customized by vendors, and software customizations offered by carriers. Why do we care about Android fragmentation? There are more than 20 Android device manufacturers producing hundreds of different Android devices, including smartphones and tablets. Moreover, Google has released multiple Android versions since 2008. On the one hand, the diversity of hardware and software within Android ecosystem implies personalization and increased usability. On the other hand, due to insufficient cross-platform testing, Android applications may not behave consistently across multiple devices and Android versions. Compatibility and portability issues caused by Android hardware and software complexity would increase the workload of developers, delay application deployment, ultimately disappoint users, and jeopardize the interests of stakeholders. However, there is still little empirical evidence on where the fragmentation exists. So, in our study, we try to search for evidence of Android fragmentation within Android ecosystem based on Android bug reports by applying topic models and topic analysis. A topic model is a statistical model for discovering abstract topics that occur in a collection of documents. There are several popular topic models applied in software engineering for traceability and information retrieval, such as latent semantic indexing and latent Dirichlet allocation. The process of extracting and evaluating the topics from a corpus of text documents through topic models is topic analysis. There are a lot of research work have been done in software engineering to study traceability, recovery, feature location, and software evolution. All the previous work have applied and supervised topic models such as LDA. In our study, we performed labeled LDA, which is a supervised topic model to analyze topic evolution. We also compared the performance between labeled LDA and LDA on our dataset. LDA is well studied in software engineering, which is an unsupervised topic modeling algorithm. It needs documents and number of topics in as input. It predicts the relevance between each document and all the end topics. LDA suffers from several shortcomings. For instance, finding the optimal number of topics n could be subjective, and some topics extracted by LDA could be hard to interpret. Labeled LDA is a novel method applied in software engineering so far. It needs manual labeling effort. Apparently, it's a supervised topic modeling algorithm. It only predicts the relevance between each document and its labels. Label could be helpful to obtain meaningful topics. N topics for labeled LDA is the number of unique labels applied on documents. Here, I want to give you a quick notation about topics and labels in our research. A topic is a word distribution extracted from Android bug reports by a topic model. A label is just the annotation of such a topic. Our methodology can be divided into two parts. The first part is to apply LDA on our original Android bug reports and labeled LDA on our labeled Android bug reports. Then we compare the performance of these two topic models. The second part is to apply topic analysis to find evidence for fragmentation based on topic analysis extracted based on topics extracted by label.da. Our data was originally from MSR Mining Challenge 2012. It's Android bug reports submitted by users and developers from 2008 to 2011, including more than 20,000 interests. We extracted vendor-specific bugs for HTC and Motorola. For applying label.da to understand Android fragmentation, we need to label Android bug reports. In order to create feature-oriented labels for Android bug reports, we studied the features in Android versions, popular applications, and hardware components of Android devices. The manual labeling effort took 60 person-hours, and we have thousands of labeled bug reports for each vendor. Our data is freely available in this URL. For each vendor's bug reports, we applied label.da on the label dataset, and label.da generated word topic matrix and document topic matrix. Each entry in the matrix is a probability of relevance between either a word or a document and a topic generated by label.da. Based on the document topic matrix, we group documents that are related to a topic by month and visualize the distribution of average relevance for some frequent topics by analyzing topic evolution. Here is an example of the topic language in HTC. The distribution of such a topic is visualized on the timeline. The x-axis is the timeline, the y-axis is the average relevance. We applied LDA on our original data who has no label. LDA would also generate two matrices, word topic matrix and document topic matrix. In order to find the most distinct and understandable topics, we tried a range of number of topics to find the best N. Then, for the convenience of comparing topic models, we labeled each topic using our manual labels assigned to vendor-specific bug reports. The labeling effort took 2 hours. In order to determine if LDA would generate similar results to label.da, we computed and compared the checker similarity of documents related to each topic generated by LDA and label.da. This plot shows the pairwise checker similarity between bug reports related to topics in label.da, which are in x-axis, and LDA, which are in y-axis. The brighter spots mean larger checker similarities. The diagonal entries are the matching labels. Most of them have larger values as we expected, such as the label browser, which other spots are quite dark. So only some of the spots with matching labels have larger similarities in bug reports between LDA and label.da. The plot of pairwise checker similarities in Motorola has a similar patterns except a smaller scale compared with the plot in HTC. The diagonal entries have larger similarities. However, the mean similarity are only 0.2 for HTC and 0.08 for Motorola. Furthermore, the number of bug reports related to the same labels in LDA and label.da are significantly different because of small p-value in the chi-square tests. Therefore, LDA cannot provide similar results that label.da does. So we come to the conclusion that label.da produced more feature-relevant topics than LDA, but it needs more efforts.
About topic analysis, we perform topic analysis based on the distribution of average relevance for the most frequent topics and the word distribution in each topic. According to the time series relevance distribution of each topic, we categorize those topics into common topics and unique topics. The common topics represent the same label that are shared between both vendors and share similar distributions of the average relevance over time. The unique topics are with the significantly different topic relevance over time, which is more specific to one vendor than the other. In our study, there are 14 common topics shared between the vendors. Let's take a look at one of the most frequently labeled topics, Bluetooth. This label shows the Bluetooth topic and the associated word list with related top 15 terms generated by label LDA for each vendor. We can see both vendors share many identical topic words. The bottom figure is the relevance of common topics in HTC and Motorola over time. From the figure, we can observe the Bluetooth topic has a cross-vendor peak with the release of both Android 2.1 and 2.2 version. Another feature of common topics is topics of each vendor tend to share vendor-specific terms. By reading the bug reports, we found in HTC there are 9 topics share the term Desire, which refer to the HTC Desire smartphone. In Motorola topics, they share the term Droid and Zoom, which refers to Motorola Droid smartphone and Zoom tablet devices. It implies the evidence that the different product lines face the different issues. For example, there is a display issue between Motorola Droid phone and Zoom tablet because of the screen size. Keyboard is one of the unique topics in HTC. We can see there are 2 peaks in the figure. By reading the bug reports, we found most HTC devices has no physical keyboards before Android 2.1. This new feature is frequently used by HTC users. In contrast, Motorola's Android devices tend to have physical keyboards, which might explain the lack of bug activities in Motorola bug reports. This figure shows the HTC keyboard relevance peak and drop out, while keyboard in Motorola is steady. This behavior suggests the hardware and software configuration dictate the importance of the keyboard topic. GPS is one of the unique topics in Motorola. By reading the bug reports and the history brief of Android releases, we found the Motorola and HTC used a different GPS software before Android 2.2. Motorola Droid smartphone used the Google Map as the GPS service from Android 2.2. As the result, this new feature contributes 3 peaks for Motorola in this figure. Software-based fragmentation. From the topic analysis, we found many topics, bug reports, and the peak in activities are related to the different Android releases, such as version 2.0, 2.1, 2.2. We noticed that the new features and changes of the system would contribute the bug reports. It would be hard to test across all of those vendors and product lines. For example, common topic Bluetooth share 2.1 and 2.2 in HTC and Motorola. It indicates the Android 2.2 has incompatibility issues while upgrading on certain devices. Hardware-based fragmentation from the topic and associated word list. We found the product lines of HTC and Motorola share 9 topics in common. Different product lines were associated with the different topic, indicating there might be fragmentation issues internal within the product line of the vendor. The variation hardware devices in each vendor is another reason to contribute the bug reports about both Android features and components of mobile devices. For example, the topic display in a Motorola correlated with the Droid and Zoom. Conclusion. In our study, we found how fragmentation is manifested within Android by comparing and contrasting the bug reports between 2 Android smartphone vendors, HTC and Motorola. Based on label LDA topic analysis, We found that different topics tend to be associated with the different products, providing even more evidence of a vendor-specific fragmentation. As a result, hardware-based fragmentation in Android is evident by differing bug topics and product-specific issues. Moreover, from word lists of different topics, software-based and hardware-based fragmentation within Android appears through incompatibility issue and portability issue. On the other hand, we compared the performance of label RDA and RDA. We found the label RDA produced more features relevant topics than LDA. However, applied label LDA need more efforts than LDA. Finally, our finding can be used to make project dashboard, process mining, and software process recovery.